Okay, so remotes. Um, so last week we talked about Git and how it had, these you know, commit objects which pointed to their parents. And sometimes we had two commits that would branch off from a single parent. And then maybe we would have a merge commit that brought two parents back together and all that good stuff, right? And we had, a main or trunk or master, which pointed to whatever the tip of that branch was. So what a remote is it's just a reference to another repository. So it's like yeah, let's just call it a link to another repo. So um, the main things that you would uh, the main porcelain commands that you would use for this would be things like git remote, and then you can do like add, I think it's remove, things like that. And what this will do is it will take some kind of a remote name. So the most common one is origin. And then that will link to something like git at github.com, Arborian, and then something like, I don't know, TCPA.
Sorry, what are porcelain commands again?
So porcelain is the things that you'd normally type, as opposed to plumbing, which is like the low level stuff. So yeah. So this is really all that a remote is doing, is it's setting up this word or this link origin, which points to some longer URL. Right. And it could be an HTTP URL. This would be like I think it's git plus SSH / followed by all that jazz. So it is possible to have multiple remotes, but let's just look at one remote for now, because that's the normal thing that you would deal with. So some of the other commands, so this is for managing remotes. This is for adding a link to a remote. It's for deleting a link to a remote. You can just do like git remote with no arguments, and it'll show you a list of all the remotes. But then the ones that you'll probably be dealing with most of the time would be things like, there are actually four that you might work with. So clone, pull, push, and fetch. So these are all commands that have to do with other repositories. So what clone does is it creates local copy of a remote, and it sets up the origin link, right? So if I do git clone some repository URL, it creates that repository locally, or it creates an empty repository, and then it pulls all the contents of that remote repository into this, and it also sets up this link origin that points to whatever you cloned. Okay? I'm going to skip over pull for now, even though we use it more. So what fetch does is it retrieves all objects from the remote. So all of those commits and trees and blobs and everything, if they're missing in my local copy, then this will pull them in to my local copy. Push will send all of the objects to the remote. Okay, and so the objects here also, in both of these cases, uh, includes branches included. But they're included as, whoops, go away, Dell. Okay, as something like origin / master, or sorry, main. So as it, if I do a fetch from origin, or I just do a git fetch, by default, it's going to fetch from origin. Then it'll pull in all of those objects, and it'll also pull in basically the latest versions of all of the branches and refs that the origin has. So if origin has a reference to a main branch, if it has a reference to a topic branch, dev, whatever, those are going to be copied in, but they're not going to be copied in just to my local thing called main or master or trunk or dev. It's going to be copied into something that says it's origin / main or origin / trunk. A pull is a little bit interesting. It is a fetch plus a merge, or possibly a rebase, depending on how you set it up. So whenever I do a git pull, it's going to first fetch, so make sure that my repository is up to date. It has all of the remote objects local into it. And then it's going to move my local branch, right? So it's going to move it to whatever branch I was pulling from in the remote repository. Okay? So if I am on main and I do a git pull, what it's going to do is git fetch and then git merge origin / main.
So the git pull is potentially destructive of your local changes?
It's not destructive. It does move your branch though.
Okay.
So
would you need to resolve? You wouldn't resolve merge conflicts though.
Yeah, you absolutely can. So let's see if we've got. So let's say I've got local here and GitHub is here, and we'll look at some of the examples. So let's say local has 3 commits, right? GitHub, and we'll call them A, B, and C. GitHub also has well, let's say GitHub just has A, right? So if I do a push, so what happens is GitHub gets B and C added to it. And I guess I should also say, main is also going to move when you do a push. And I should go ahead and put that. Main is here. Okay. So the push actually is going to copy these 2 things over. And then it's going to, and I guess this was the old main, ... That used to be main on GitHub. So sometimes this will fail. The specific case that it'll fail in is when I've got some D here and I try to push. If I try to push in this case, in order to move main down here, it would have to do one of 2 things. It would either have to create a merge, well, actually 4 things, I guess. Create a merge, it would rebase, or it would have to actually just forget about D. Well, it just refuses to do those. And so what it will do is it'll tell you that it cannot do non-fast forward merges on remote. So that'll be the error message that you get when you try to do something like that. And it will reject it. So then it will prompt you, do you want to force push it? So if you push with -- force, what it does is it just forgets about D altogether on the remote. So force push can be destructive. And so I like to say, don't use a force push unless you are a Git Jedi. So anyway, force pushing, blah, yeah. Okay, so, but that's what pushing does. Pushing is going to copy my local objects here over there, and it also copies, it moves the mains, but only if it's fast forward, right? Okay, so let's look at a fetch. So let's say we start out in this same, we've got A, B, and C here. And okay, let's just say we're not doing anything with that right now. GitHub also has now A, B, and C. So let's say we successfully did that push, and then Dustin comes along. Dustin. And Dustin makes another commit, and somehow he goes ahead and he pushes. And so now this has a D, right? So D for Dustin. There you go. So this is what we have here. So what I have before the fetch here is I've got main is pointing here. I also have origin main, which is what I think origin is pointing to, right? So then I do my push, or I do my my fetch. What happens in my fetch is it will make sure that it's got all the objects that are on the remote. So goes ahead and creates this D, and it moves origin main here, since that is something that it's pulling from the remote, but it doesn't move main. Right? Main doesn't move at all. If, on the other hand, I did a pull, then if it was a pull, then main would move down to D. Okay. So, and I can just draw that as well here.
What happens if you try, in that scenario, you try and do a push because you're unaware that Dustin has made a commit?
That's this case up here. It'll reject it unless you force it. Yeah. So if it can't, so fast forward commit or fast forward merges are kind of safe, right? It's not changing anything. It's not forgetting about anybody's commit anywhere. It's just moving the branch forward. So typically when something goes wrong, when you try to push, the correct answer is not to force push. The correct answer is to pull. So let me show the pull. So if we're here, again, it's just the same thing. We got A, B, and C. A, B, C, and D. And main, of course, nothing's going to change on the remote when you do a pull. And I guess I should put, what is it before the pull? So before the pull, again, we have main and origin main. Both of those point here, right? So I do my pull. And what I get is, number one, it does a fetch, like we were talking about, right? So fetch happens. And we also then get main and origin main. Those are both going to be pointing here. So the remote, we call origin main a remote branch because it's a branch that represents our latest knowledge about what's going on the GitHub remote. Right? It doesn't necessarily mean that it's what the GitHub remote actually has. It's just the latest that we've heard. Right? Main is our own branch. So nothing on the remote can change our local branch. It's only when we merge or we do some kind of a rebase, that's when this can happen. That's when our local branch can change. Okay, so that's mostly it. So I guess the rules, I'll just kind of give this as a, overall remote rules. Oops. Okay. My drawing area is not quite that high. Okay. Never force push shared branches. Okay. So that's because if you force push, it just forgets about this. Somebody else then tries to push and they're like, wait a minute, my reference to origin main said, is pointing to this other commit, which is kind of gone. So you can end up having people with dueling branches. So never force push shared branches. Pull push to resolve conflicts. So these kind of go together, right? So if push fails, that just means you have to pull first. It doesn't mean that you need to force push. There is one time when it's okay to force push, and that is your private branches. And so this is where we would have things like DN as a prefix, or RC, or DJ, or JJ prefix. So this indicates, and I guess at some point we're going to have some AH branches, right? And probably some DK branches. Oh, wow. I'm going to start thinking Donkey Kong every time I think of her if she ends up working here. So anyway, but the idea here is these are safe to force push. You would, times that you might need to force push. If you do rebasing, like interactive rebasing on your branch, then it's not going to accept that push if you've pushed it before, because what ends up happening, let's see, with pushing. So what I've done, what a rebase -I means that I've done is, I've got, my own work here, and I had a whole bunch of stuff. And the same thing applies to any kind of a squash commit. And usually, oddly, when you do a rebase -I, it's very common that you don't actually rebase anything. You're just rewriting the commits since a certain point. But let's say, I've got something like origin, or sorry, origin main. It's pointing up here. And then I've got RC 1, 2, 3 pointing here, right? So I rebase -I with a squash, squashing the commits into a single commit. So what I end up with there is, Git doesn't really destroy anything. So it still has these commits out there. It still has O main pointing there. But then what it's done is it's taken all of those commits and it's made them into a bigger commit, which is now what RC123 is pointing to. And this is what's actually happening when you do a rebase -I. Right? So these are still there. They're like in the repository. They're just not being referenced by anybody. Eventually, they're going to get garbage collected. So they'll be swept up and the space will be reclaimed.
Is when you make the big commit, is there ever a problem with space, or should you be, that's something you should be aware of if you squash it?
Yeah, typically not. You don't need to worry too much about, like, you're talking about disk space, right?
Yeah, or when it's a bad idea to squash if it ever gets too big or something. Yeah.
I mean, the only reason that you really do this, well, two reasons, I guess, that you do a rebase -I and squashing your commits together is one, you have a whole bunch of intermediate commits where you were just maybe, I wasn't sure if this was going to work, so I did a quick, I'll a lot of the time have a commit whose message is just WIP, work in progress. So I commit it, I try to do something, it works. So then I make another commit saying what I was actually trying to do. So a lot of these, WIP commits, they don't add anything to the history, right? Keeping them around doesn't help anything. So it's better maybe to take them and to squash them all into this commit, right? So combining, and it actually does reclaim a little bit of space when you do that, in terms of like the way that it's storing it. So once these do get garbage collected, it'll actually be shorter. It'll store less data, but that's not why we do it. We do it to clean things up. We also might do it because we're hitting a ton of merge conflicts when we try to rebase somebody else's code, or we're trying to pull in master with a rebase, or sorry, main with a rebase, something like that. And we want to just reduce the number of commits where we've got to resolve conflicts. So you might do it there as well. Right. So this is what happens when you rebase, right? That's the state of my local repository. On the remote, and I'll change my color theming here again. So what remote has, so let's say we did a push at this stage. So what origin has is this thing that says RC123 is here, main is here. And that also means that over here, I've got origin RC123 is pointing here, right? Because remember, these origin links, these remote branches, they're just references to, it's a bookmark to what we think the actual remote has. Okay, so what happens when we try to push that? Well, we're going to get a conflict, right? Because it's going to say, well, you had 1, 2, 3, 4, 5 branches here. And you want to create another one here. That's all fine and dandy. It doesn't care about that. What it cares about is losing this RC123, right? It doesn't want to lose that branch, because otherwise just assume that it would all go away instantly. So you could have work that's being based off of that, and then that would be lost. So when you do a force, what the force does, force will move that branch anyway. Well, I shouldn't, sorry. Shouldn't actually erase that. What I should do is I should erase that, right? So that's what the force does, is it forcibly breaks this branch and it points it over here instead. And so that's why you can do this with your own private branch, because you're the only one who's following that branch. The problem is, what if somebody else has pulled this out? And RC123, they've started making some commits off of that. Then they try to push, and it says, oh, you can't push without force, because you'd be losing work, because now all of a sudden this guy would be lost. Okay, so that's what's happening when you do a rebase-i. That's why rebase-i is not going to, it's not going to let you push it unless you force push it in that case. All right. Does that make sense as to why it's complaining about it?
Yeah, because I guess, yeah, you went off a branch and you just kind of disrupted the flow. So everybody else after that has to do the same thing.
Right. Yeah. So that's what's going on there. And that's kind of, I mean, that's almost it. There's one other thing, I guess, that's important to understand, and that's tracking branches. So
I have a question.
Oh, go ahead.
Just wondering, what are the situations in which you would lose your work in these scenarios?
Like lose it,
because lose it, because that's kind of everyone's fear, messing around with it, right? It's like you start messing around with branches and you lose what you've been working on for the past hour or whatever.
So if you like permanently deleting things is hard, which is why Git is challenging when you're trying to redact anything from the repository, right? Whether that be credit card information or passwords or keys to a repository, whatever type of thing. It's very hard to actually lose work. But let's say you didn't come to the tech talk until late today. Dustin, just kidding. But yeah, let's say you didn't, you missed this part. Actually, you missed this rule right here. Never force push shared branches. So you force push main or trunk, right? Or dev or whatever the main development branch is. And somehow you convince all of the other developers on your team that they need to use your version of dev instead. So they need to just delete all their local stuff, clone everything afresh, and start from your dev. That's one way that you could lose work permanently. So
what about when resolving conflicts?
So when you are resolving conflicts, you are kind of choosing. So you're choosing either how to rewrite one commit or you're choosing how to create a merge commit. And so whatever changes you make to the files at that point just become the new snapshot, right? So if the changes that you make and the edits that you make to those files get rid of work that you've previously done, then it goes back to the state that it was at earlier. Now you still have the history of what it used to look like. You have the history of what happened right before that merge. I guess if you're doing a rebase and you're rewriting a commit, then you could maybe lose that history. Because in the case of a rebase, it's kind of like, actually, let me not. It's going to be hard for me to delete all of this stuff here, isn't it? If I cleared everything, I think it would clear the whole thing. So let's just mark it out. Okay. So if I'm doing a rebase, that's usually because, I've been working on a topic branch. And so I've got my 3 commits right here. Actually, so if I started out like this was origin main, right? So I'm doing my commits, and this is my RC123, or RC13, sure. And so then I do a git pull, and I've maybe set up my sorry, I do a git pull, and what I discover is that origin main is now here, right? And then I want to do my rebase. So when I start to do my rebase, what it's actually going to do is it's going to say, well, what are the changes here? Computes these deltas. And it's going to try to compute, it's going to try to apply those same deltas onto this. Right? So actually, let me label these. So this is going to be A, B, and C. Right, so it takes those deltas between these 2 commits, and it tries to apply it to this commit first. Right, so now it's actually, is that right? No, I'm sorry. It's going to try to apply these down here. So we'll call this A prime. Same deltas, right? But what happens if it makes a mistake? Right, so there's a conflict here. So in this conflict resolution point, I get the chance to edit the files, right? It'll give you your rebasing. It tells you you've got a conflict, so you need to do something about that. So I edit the files. If I change, like if I delete some of the changes from this delta and then add them and then rebase continue, I could lose those changes, right? If I just delete all the things that I did in this delta, then you could lose work there. That's one possibility. I guess, and then this gets repeated as it's doing the the rebase there. So that'll be delta B, that'll be delta C, right? If I tell it that everything was successful by adding those files, then it will go ahead and move this down here. All right. Does that answer that question? Okay. So, yeah, it is pretty tough to lose work permanently. All right. So now tracking branches. So I guess I'll create another whiteboard for that. So tracking branches. So when I do git clone some, repo, that automatically sets up, and I think you can maybe give a branch here, but I'm not positive. I know it used to set up a master branch. I don't know if that's changed. And what it does is it says master is going to track origin master. And what that means is if I do a git pull on master, then it's going to do its fetch, and then it's going to try to merge in master. So technically, git pull looks like this: remote branch. So that's the full stuff. So if I don't specify these, it's going to look inside its configuration to see, well, is my current branch tracking some remote branch? And so if I'm on master, this will normally fill in origin and master or main. But I can also track other branches, right? So if I, let's say let's see how to do this. I think if I do a git, I think mine automatically sets this up. But normally if I do a checkout, something like RC123, if there is an origin RC123, it automatically sets up tracking on that. And so let's actually look at that in a repository here. So let me switch over here. And okay, so this is the TCPA repository. Should be lots of branches. So these are all the branches that it knows about, right? So let's look in the actual git config file. Okay, so these are some of the things, and normally I don't touch this manually, but this is basically where it is actually, this is where Git's storing some of these things. So the remote origin, what this is saying is if I, this is its remote, or this is the actual remote for this. And when I do a fetch from origin, it wants you to get all of the heads are going to track the remote heads. So I think that's what that's saying. The syntax is a little bit weird to me. For my trunk branch, what this is actually saying is the remote is on origin. Whenever you do a git pull, if you're on trunk, it wants you to merge in the trunk from origin. And this flag also says, please do a rebase instead of a regular merge. So that's just a flag there. Same thing for the bot updates. So this has got tracking set up, and dev, it's also got that set up. Okay, so let me verify everything's clean. Okay, cool. So let me check out. Oh, come on. Does that work? It does. Okay, so when I do a git pull, notice it's just pulling stuff in directly from dev. So if you see, it's enumerating the object. So this is it figuring out what's missing in my local repository. Counts them, compresses them, brings them back, unpacks them in my local repository. The second thing that it does is it's doing a rebase. And so it's doing a rebase of the current branch dev to whatever it just pulled in. And that's just because I've got it set up to rebase when pulling instead of merging when pulling. And so if I had some commits on my dev, it would have tried to rebase those commits onto what it just pulled in from origin. So this was a fast forward update. Didn't need to do anything, so I just moved the branch. Okay. But now let me check out Tech Talk. Whoops. Oh, right. Not TC. Oh, come on. I know my initial. Forgot about the branch. Oh, is it just -B? Sorry. Just trying to be all special. Okay. So when you check out -B, that creates the branch and it checks it out. So if I actually do, this is another neat command. If I do a git log, --1 line. So I've got a bunch of things that I think are set up in my own Git config. So let me show that. I thought I had. Maybe I didn't have anything set up on the logging. Maybe that's just what it shows you. Okay. So anyway, the one line can be helpful if you want to see a bunch of stuff here. So this is what this is telling me is, actually, let's get rid of that all. I don't know why this is giving me two things, but whatever. Can I just do this with one line? Nothing else? Okay. So I think because I was doing -G for the graphical, it was doing a little bit more. We don't do a lot of, we haven't had any branches that introduced merges in our tree because I guess we've been doing all rebasing. Okay, so this is what happened. So I got dev and origin dev both pointing to this latest commit, and it's also RC Tech Talk. So if I make a commit now, it'll move Tech Talk. It won't move origin dev or dev, right? So let me go ahead and make a commit. So I made a change. Add everything. So you see Tech Talk move forward one. Origin dev and dev are still back there. So now I can push this. And if I just push it with nothing, I think it's going to create the branch remotely, since remote doesn't have a Tech Talk. Right? So it tells me this. So that created the branch, made sure that all the objects were up there, which is just one object it needed to add. But now if I do a git pull, it tells me that there's no tracking information. So even though I pushed it, even though it created the branch remotely, it didn't set up that link between my local branch and the remote. And so if I want that, then I can actually set upstream to like this, or I could say git pull origin RC Tech Talk. So that was already up to date, so I didn't need to do anything. All right, so since I have not set up the tracking, there's actually nothing that it's storing about this branch. So there's no configuration stored because I've got no tracking information. Right, but if now I do this little command that it's recommended that I do, git branch set upstream to equals origin RC Tech Talk. Okay, because it's TC, because I did that again. Okay. branch RC Tech Talk set up to track remote branch RC Tech Talk from origin by rebasing. So it added this little section. And so it says, whenever you do a pull, if you're in the RC Tech Talk branch, make sure that you merge in this remote branch here. Okay, does that make sense in terms of how that all works? Okay, so I don't actually want this. So I'm going to go back to the auth git branch -d RC Tech Talk. Okay, it tells me it can't do that, and that I'm a bad person. Oh, actually, it doesn't tell me that because it's got a remote. So that's fine. And then this is always where you look up something. It's how do I delete a remote branch in Git? So deleting, oh, come on. Okay. Yeah, it's always going to be a push. Okay. So it's super weird. Git push delete origin, or sorry, git push. Actually, I think I might just be able to do -- delete RC Tech Talk. Nope, I got to do origin. Okay, super weird that you do a push. I don't know. Yeah, I think it's because push is going to be modifying remote refs, and that's what's going on there. But anyway, that's the weirdness of all of this. If I do my git branch -r, I see all these remotes. And if I just look for I got a bunch of remotes that probably should go away. Or remote branches that probably should go away. But you see that there's no Tech Talk, and that's good. Okay. So any questions about dealing with that sort of thing? So let me show one other thing. Go ahead.
I got a question. Your git config.
Yeah.
Did you customize that yourself?
The home directories .git config I did. Yeah. So I don't think I'm doing anything with this OAuth token. So if this ever makes it onto a video, we probably should delete that. You know, having OAuth tokens in videos is always a bad thing. But anyway, some of the things that you might find useful. I mean, the colors are kind of nice if you like the colors that I've got there. Having a global git ignore is nice. So this makes sure that it will always ignore all PYC files or things like that. The white space fixes, these help a good bit. So anytime I do a commit, it's going to automatically remove any trailing spaces, any spaces before a tab character, and any carriage returns at end of line. So that's like a Windows thing. Windows ends its line with 2 characters. One is a carriage return, which means go back to the beginning of the line, and then next one is the line feed, which means go to the next line. Linux and Mac just use the line feed or the new line character. Yeah. So, but these are the kind of white spaces that it'll remove. Branches are always set up to rebase, and if I do if I check out a branch, then it automatically sets that up as a tracking branch. That's what this auto setup merge is. So if I actually check out something from the remote, I guess I didn't show that. It'll automatically set that up for me. And if I push, and I don't specify a branch to push, it will just push my current branch. You can also set that up to do all branches, I think, which is probably not what you want.
Okay.
Okay. But yeah, and then the refs, again, in my refs directory, there's no magic here. This is where Git is storing all of this information. So these refs, what do you suspect is going to be inside this file right here, refs heads dev? Any
all the
thoughts?
spots where you branched off.
Well, let's look at this. Okay, so it's 41 bytes long. Any suspicions as to what the contents look like before I cat it?
Yeah.
Just the hash. So if I do a git log, so this one starts with EA8FD. Actually, let's look at this. EA8FD. Whoops. Oh, let me do -- all. Yeah, there you go. Origin dev. So that wasn't being included in my log originally. So EA8FD, that's the hash that I was pointing to. So it's just storing the hashes. That's what all of those files are inside your refs. So if we look at all of these heads, these are all of the branches that I've got locally. And yeah, it does. Actually, how about I just find refs, type F, yeah, and then cat each one of those. Yep, just a whole bunch of refs. Well, one of the first one here is actually, what was that first one? Oh, the head. So the head ref is a reference to another ref. So saying that head is tracking whatever trunk is tracking, but the others are actually just commits. And if I sort them, there's probably some that are tracking the same commit. Like these two here are tracking the same commit. These two are tracking the same commit, and so on.
What is the type F in the find refs thing?
Files instead of files and directories. So if you just do find refs, I'll get directories as well. Yeah. Okay. So one other thing. Actually, any other questions about this before I go back to the whiteboard?
No.
Okay.
And you said that the double refs was two branches referring to the same commit?
Yes. So things like a remote dev and local dev are pointing to the same commit, and so they'll have the same contents in that file.
Yeah. Right.
Yeah. So you also mentioned that you're interested in setting up keys, right? So Git, actually, let's say communicate, or, whoa, that was an interesting one. How did I even? Okay, not sure. Oh, I somehow got into select mode. That's not what I want. Okay. So connecting to remotes. So we can certainly do this if it is a file. That's easy. All of the stuff that I was talking about with remotes, if you've got a repository checked out to 2 different locations on your laptop, you can pull from that other location, right? You just say, set the remote to point at a different file, and it will find all of the stuff in that other file. So we won't worry about that. We can do HTTP, and that requires the password to push, and sometimes also to pull, right, depending on how it's set up on GitHub. And then there's another transport which we call, which is SSH. So SSH stands for the secure shell, and it's not mainly used for Git. So what it's mainly used for is just getting a terminal on another machine so that you can type commands on that other machine. And SSH can use lots of different ways to authenticate your user. So the main ways is its password or a public private key. And so this is the way that we tend to do things, is using the public-private keys. It's a lot easier to deal with, it's a lot easier to just deal with because you don't have to type your keys over and over again. So the way that this works is GitHub's over here. Wow, this is being really slow for me. I don't know if it's being slow for you. And then this is local. So when I SSH to GitHub, wow, this is becoming unreasonably slow. So I basically offer it, I say, hey, I give it the private key. And GitHub says, does the private match? Okay, this is ridiculous. Let me see if this I got a window over here that might be slowing things down. I don't know why this is being so slow here. Okay, does it match the public key? Oh, that's much better. Does it match the public key on file? So I'm not actually sending the private key. There's other cryptographic stuff going on, but basically I'm authenticating. I know what my private key is. I send some token that indicates that. GitHub says, does your private key match what I have for your public key? So the reason why I use private and public keys here is because I don't want GitHub to have my private key. I might be using that for lots of things. And the way that private keys and public keys work is basically if you, how to explain this? The private key has all of the information for both public and private. So I can generate a public key from a private key. So think of that as being kind of the master idea. And what I can do if I've got a public key is I can verify, actually, sorry, it's been a while since I've actually tried to state this precisely, but so let's say I just have some random string, I'll call it a nonce, and I want to encrypt it with my private key, right? So I give that encrypted value. I also give the nonce itself, the thing that I encrypted, and I package both of those up and I send them to GitHub. GitHub can actually verify that big package with the public key. So it's a way for it to check to make sure that, yeah, you claim that you claimed to have encrypted this nonce with your private key, and it looks like that was true, right? So that's what it's able to prove with that public key, is that in fact you did have access to this private key. And so that's the idea of why we're doing that. And so that's just how SSH works. So in SSH, it will say, hey, I've got this, I'd like to authenticate using a public key number 123. And GitHub's like, oh, cool. I've got, it turns out I have a public key 123. Go ahead and send me something that is a proof that you know the private key for public key 123. And so it sends that proof and it lets you in. Does that make sense? I know I'm kind of hand waving and my diagrams are not necessarily useful. Okay,
right.
so
the I guess the public key is just like a general key to see who you are. And just to make sure, it's almost like a two-factor authentication, where they say, give me a public and then send me the private just to make sure.
So kind of. It's the public key is kind of a verifier. So if I encrypt something with my private key, it can be decrypted with my public key. Okay, so it's like there's one key that you use to lock something, and there's a different key that you use to unlock it. Does that make sense?
Okay.
So it's not something that works in the physical world too well.
Yeah. Yeah.
But yeah, so you can lock something with a private key, but you can only unlock it with the public, so you lock it with a private key, you can unlock it with the public key.
So they're kind of paired.
They are definitely paired, yeah. And it turns out the private key has enough information in it that you can get the public key out of it as well. So if you've got the private key, you've got the whole key, right? But the public key is something that I can take and I can just expose it, and I can say, you know what, I'm going to be sending you some data that's encrypted with my own private key, which I'm not going to tell you what it is. But to decrypt the data that I send you, here's your decryption key. That's what the public key does. Okay, so it's like there's one key to lock, one key to unlock. And so that's how it verifies who you are, is it basically says, you know, I've got public key, or I want to authenticate using public key 123. And by the way, here is my verifier. What I've done is I've encrypted this string using my private key. You should be able to decrypt it using the public key. And, you know, I don't actually send you the nonce. I think that GitHub sends the challenge, and then I have to encrypt that challenge using my private key and send it back to you. And then GitHub says, yep, that's correct, because I can decrypt what you just sent me. That proves that you must hold the private key. So it's all about proving that you have certain secrets. Okay, so the public key is completely public, right? You can put that on Twitter. And in fact, some people do. So they'll actually do this keybase.io, I think is what it is. And it's basically verifying, you know, here's my public key. So if you ever receive a message from me and I've encrypted it, then you can decrypt that message using that public key, and it verifies both, you know, the contents. It decrypts the message contents, but it also verifies that I am who I say I am.
All right.
Okay, so what one of the things that SSH can do is you establish the initial connection, and it uses with, you know, say an RSA key. That's just the type of encryption that establishes this connection. So once you've got that connection opened up, we're not going to do a shell. So normally you just get like a bash prompt. GitHub doesn't give you a bash prompt, but what it does let you do is it says, hey, I'd like to create a tunnel. This is my tunnel. And I'd like to run git commands over that tunnel. And so we can do pushes, or sorry, we can do fetches. We can do pushes. Right, so those fetch and push commands will go over there, and it's all going over that git tunnel right there. And so that's why sometimes you'll see it called git plus SSH. Wow, it looks like I'm getting really angry right there. Shit. Okay. Anyway, but that's what you will sometimes see that called git plus SSH as the protocol, because it's git over SSH. Right, so we establish the connection, and then it establishes another connection inside that RSA connection. So Git doesn't have to worry about verifying who you are. It already knows who you are because you managed to connect using your private key over SSH. Okay. And the way that you actually create these private keys is SSH, I think it's -keygen. And that will just create a private key. And so if I show that, so actually see this in operation, then I can say, so it will, you know, by default, it wants to say that as the ID RSA. I don't want to do that here. So actually just say test key RSA. You can password protect this. You're not required to, like SSH doesn't make you do that, but that would just require you to type a passphrase every time you wanted to look at this. So it's like a local encryption of this on the file that it's creating. Has nothing to do with offering the public and private keys. It's just in order to load it from the disk, you can type a passphrase. So I'm going to make it Arborian. Arborian again. It gives you a fingerprint. That's just like a little bit of a hash on the key. it gives you some art, which you can use to verify the key if you want to. Not something that we actually really use here, but what I do have is test. Oops, didn't it save it? Okay, yeah. Yeah, test key rsa.pub. This is my public key now, so let's look at that. So your public keys look like this. So it's an SSH RSA key. Obviously, that's not encrypted. This is encrypted. And then it has a little comment on the key. It doesn't matter what's in the beginning. Well, I guess the beginning just tells you what kind of key it is. The ending is just a comment on the key. So it by default just tells me it was my username on, at my local machine. Right? So that's the public part. The private key is this thing. And so this has got a whole bunch of crap in it. This is what you don't share with anybody. Right? So you keep that locally on your machine, probably in your .ssh directory. So this is my proof. So if I use this key to encrypt something, people can decrypt it using this key, this shorter key. Right? Turns out they can also use this shorter key to encrypt things, and I can decrypt it using my private key as well. Other people with the public key would not be able to decrypt something that was encrypted with a public key. So if you wanted to send me private messages, you can encrypt it using my public key, and I would be the only one who could read it. Right? But once you've done that, once you've created those public and private keys, sorry, it's test key. Yeah, let's remove those there. Then you can come over to my sharing my my Google here, or my can you all see my screen?
To your browser.
Yeah, my browser. That's what I meant to say. Sorry. So let me jump on GitHub here, and I just started using this Chrome, so I need to tell it to stop trying to save my passwords because I'm using something else. But I've got my two-factor auth set up here. And so I don't actually want, well, actually here, I'll just go over to my own stuff. Is it my setting or my profile? No, it's not my profile, it's my settings. So in settings, if I want GitHub to know who I am, then what I've got to do is come up over here in SSH and GPG keys, and right there, SSH keys associated with your account. So I added this account or this ID RSA on November 6, 2019, right? So I use that to do pushes and pulls on GitHub. And basically what I do is, and that corresponds, I think, to the one that's in my SSH keys ID RSA. Let's see if it's, maybe it's 2019.pub. Oh, I don't even know how to do this. I don't remember how to do the fingerprint of it, but it's something like that. But anyway, once you've created this, we can just say new SSH key, and that's where you paste it. So it's whatever you want to upload it. Once you've uploaded that, then you can push and pull using that SSH key. And the way that you would configure that is in your SSH directory. So SSH config. I've got a bunch of stuff in mind, but where is my GitHub? Certainly I've got something with, or maybe I didn't. Maybe I just said it's using my default key, my ID RSA there. Some really, really old stuff.
We're still looking at your GitHub page.
Oh, sorry. I was looking at my SSH config. I meant to switch it, but my SSH config, it turns out, doesn't have a reference for for GitHub anyway. So I think I just used my default key for that, and that's why it's able to work out. But if you were to, so there is a guide to generating your SSH keys, and then the way that you might, let's see. Yeah, I don't remember the specific syntax on that. But I guess one other thing that I will mention, or did I just forget what I was about to mention? I might have just forgotten what I was about to mention. Oh, agents, right. So if you are doing things with GitHub, or sorry, with these SSH keys, there's one other thing that is useful. So, and that is having an agent around. And so I mentioned that you can have your private key set up here. So private, and your private key can have a local, a local password on it. So that's my little pathetic attempt at a lock, right? So in order to actually establish a connection, I've got to enter in that passphrase. And you're like, well, that doesn't help me, right? Because now that just means that I've replaced one password with another. So what the SSH agent does is I can say, SSH add, we'll call this ID RSA. So what this will do is it will take this and it will put it in into memory, into the memory that the SSH agent is controlling. So we'll call this memory. And it's got my ID RSA, but it is not locked. So that's my unlocked padlock. And so then when I do an SSH connection, SSH can say, hey, agent, do you have that key, by the way? And the agent's like, yeah, sure, here it is. And so it basically, SSH will retrieve the private, private key so that it can establish its connection. And that's what the SSH agent is doing. So typically the SSH agent will start running when you start running your laptop. So if you're on Windows services for Linux, that's automatically, actually, is it automatically running? Let me actually look at mine. I might actually have my own that's set up here. So, whoa, what on earth did I just do? That is not what I meant to do there. Oh yeah, so I've got actually a keychain function here. So that is my SSH agent. So it found out that I'm already running one on, I guess it's on port 428. So, come on. No, maybe not. I don't know exactly how it's doing it. But somehow it's able to be there. Anything that I load into its memory, I can then use to authenticate without having to enter the password. So when you do that SSH add, then, I switched screens without telling you what I was doing. When you do the SSH add, you do have to enter the passphrase. All right. And that's how it unlocks it, stores it in memory so that later on when you're going to be authenticating, you can grab it. So if you reboot your machine, you'll discover that you've got to SSH add your keys again. So if you try to push and it says, enter passphrase for blah, 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 you might just want to hit Control-C, do an SSH add of blah, 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 whatever that key is that it's trying to use. And then it won't ask you again when you try to push. Okay. Any other questions? Gone a little bit over.
No, I think I'm good.
Okay, so everybody ready to do some here. Now I think I should be able to do this. My Octocat. Okay, not an artist at all.
I see. Yeah.
Yeah. Thanks. So there's my Octocat.